I'm Rajesh Sura, Head of Data Engineering and Analytics at Amazon, and definitely thrilled to be here to discuss one of these fundamentally, redefining topics in our technology landscape, which is AI native analytics. For years, we have heard the promise of data-driven decision making, but the reality has often, been a long manual journey from data ingestion to an actionable insight. Organizations have spent millions on dashboards, self-service tooling, and at the end, only to find out that the business analysts or the data teams are spending 60 to 80% of their time only on data wrangling and report validation. They're not really spending their time in strategic thinking, and we are now in the space where large language models and advanced AI are bringing a foundational shift. We are moving past simply visualizing data and entering a space where our systems can start reasoning, they can start conversing, and at the same time advise on what is the next best action. So this isn't about better dashboards, it's about building intelligent and conversational decision systems, that would redefine the role of every analyst, a manager, and even an executive in the enterprise. So this shift is what I call AI native analytics. It will require new tools, new architecture, and most importantly, a new mindset. So over the next few minutes, we'll go through a vision for this transition and a clear, directional roadmap on how we can get there. To understand, where we are going, let's quickly anchor, ourselves in the past. We can break the history of enterprise analytics primarily into three major waves. Like 1.0, which was very descriptive. So this was the era of what happened. Think of it as early 2000s, where we had static reports, simple dashboards, or weekly email summaries. Most of it was driven by IT, and obviously they were very slow and very reactive. So the analyst's job was simply to report the past, looking at the monthly sales report, showing that the revenue is down by X% in Northeast region. That's it. You know the fact, but you have no immediate context. And that's when we moved into an era of diagnostic and predictive intelligence, which I call like BI 2.0. So this is the era where we define why it happened. Starting around a decade ago, I would say like 2015, we introduced self-service tools, robust data warehouses, and even our first machine learning models. So these helped slice and dice the data to diagnose, what is the root cause, and at the same time forecast what are the future trends, what is the demand. So this was the democratization of data access. Extending to an example, we were able to drill down, for instance, a sales dip, and identify, hey, this is primarily due to specific product line being out of stock for 4 days. So that's a diagnostic root cause. But then a machine learning model was also able to predict that if the inventory levels doesn't change, we will lose X million in the next quarter. So that's a combination of both diagnostic and predictive. But still, it only helped us tell why it happened and what would happen. But it doesn't still tell us what needs to be actioned, in order to ensure we have the right outcomes, or in order to ensure how do you avoid what bad is going to happen, or how are you going to be prepared for what's coming next. So that's where AI native and conversational analytics comes into picture. So this is the ultimate stage, what should we do? We are moving away from reports to basically autonomous decision systems. This is where AI moves from being a background model to a proactive conversational partner. So it reasons, it kind of generates narratives and provides a clear prescriptive recommendation. So say the whole BI 3.0 approach is where a system automatically goes flags an inventory issue, but it will also immediately suggest a supplier resourcing change and draft an executive's alert that explains, like what is the predictive uplift in the revenue if you take this particular action. So this is what we call as insights into action. So the shift, right? The shift in BI 3.0, it requires us to fundamentally expand our capabilities beyond the traditional three dimensions. When I say traditional three dimensions, I'm referring to descriptive, diagnostic, and predictive, which are now, like table stakes. So they're definitely, like the fuel for AI engine, like the prescriptive layer, right? This is the, like let's talk about the prescriptive layer. This is the action layer. It answers what should we do. It is the ultimate goal, and it tells us it tells the user to do something, whether it's from changing a price or reallocating an inventory, or even like flagging a vendor. And then comes the topmost layer, which is cognitive AI. So this is the pinnacle. It is what enables the prescriptive to be successful. So the cognitive AI is basically the ability to reason and explain its actions. So it answers, why should I trust you? And is this recommendation make any sense? And what facts do you have to back up this recommendation? So it provides the rational, it provides the like casuality and the transparency for a recommended action. So we position the cognitive at the top because a prescriptive model without a clear and cognitive explanation is just a black box recommendation. You can't simply, go ahead and create a deal just because AI has recommended to do it. So we are moving towards systems that are not just accurate but also accountable. I can provide a quick manufacturing example. It's not enough to simply predict when a mission will fail. AI native system will dynamically suggest the optimal maintenance schedule for the minimum downtime in order to eliminate or reduce those failures. Let's be blunt. You cannot have AI native analytics without AI native data. So data is basically the foundation, and it's the most critical and often the most neglected part of this transformation. It is very true, AI is ready, to bring in a transformational change across every process. But what is also true is your traditional systems and your traditional data sets and your traditional metadata to bring in information about your data is not ready. So until your data is ready, you can't bring in the right value from your AI data sets, because it's no longer the saying garbage in, garbage out. It is now garbage in and disasters out, because AI can reason, AI can, action on behalf of you. So you put in garbage, you should be expecting disasters. So yeah, the key insight here is paramount. Informed metadata enables AI to reason over data, not just query it. So imagine you have a metric called, gross sales. So to a traditional SQL query, that's just a column of numbers in a table. It has no meaning beyond its numerical value. But to a cognitive AI, that is useless. An AI native system needs rich metadata that defines it completely. So what it looks like, this metadata would specify gross sales is calculated at the end of the day, filtered by region X, excluding sales tax, including returns, and derived exclusively from a point of sale system, so and so. So that's what we call informed metadata. So every metric, every data field in your tables or in your systems should have informed metadata, and this rich metadata will allow will allow the AI to understand what is the context, like what are the business rules, and what is the full lineage of this data. And this can be achieved through like multiple things. Number one, unified and compliant data pipelines. So ensure all of your data is integrated, clean, and trustworthy from the start. Number two is contextual semantic layer. So this is where we define the business language. It ensures that what marketing team says as a customer and finance teams knows that they are talking about the same exact entity. So that's what is contextual semantic layer. So this single source of truth for definitions is what AI will use to converse with the human. And number three, rich metadata lineage graphs. So these graphs, they map out every step a data point like takes, like from raw source to a final metric. And this lineage is what allows AI to immediately trace metric error back to a source system failure, and rather than forcing an analyst to manually investigate. Last but not least is tiered storage for sustainability. So we must manage our massive data sprawl responsibly. Like tiering old data to less expensive, greener storage ensures our architecture is like cost efficient and environmentally sustainable. So I'm not saying that you should always have like a centralized data repository and a centralized tooling. What I am referring to here is, if you want cognitive AI to reason for better and to reason more responsibly, you need to have a centralized, like data lake or a data mart, and a centralized contextual semantic layer on top of it, which would inform everything about this data. And then you enable business users to build their own, like custom agents or agentic workflows, or like research scenarios, whatnot. All of these front-end workflows, which business users can like build all by themselves with no code or low code, should tie back to this centralized like contextual semantic layer. So everybody, when they are talking, when they are making a conversation with AI, it should understand the intention behind different shape and form of a prompt and provide consistent outputs. So that is only possible with this informed metadata architecture. And metric lineage, this is one of my favorites. We saw machine learning models provide recommendations and whatnot. But one thing that totally differentiate machine learning models with AI is the rule-based enforcement. Today, if I take retail industry, everything changes very quick. Like you can really make use of real-time data and instantly produce actionable recommendation. And that could be like instantly going and changing the price of a product or creating a promotion to liquidate your unhealthy inventory and whatnot. So it is super important for AI to understand the entire metric lineage and decide what metric has caused a change in what metric. So what I meant by that is, if your sales is down, you should not be defining some rules telling that, okay, hey, sales is down, so you need to now go look at inventory level or out of stock level, or like a price change. Rather, there should be a complete lineage of metrics, like what could impact what, and that lineage of metric is should be provided as a knowledge base for AI. So now, when a metric is down, when your inventory levels are out of stock, it has to understand automatically what could be a driving factor and then reason on top of those driving factors. So that's what a metric lineage would enable AI. So let's start with dependency mapping. So AI builds a complex map that shows how every metric flow from like a source system through transformations into your final dashboard. So when an anomaly is detected, AI knows exactly which upstream data transformation or a business rule change or a source system change is responsible for that anomaly. So, for instance, if your average order value metric suddenly spikes, the dependency map should show that a code deployment which happened yesterday changed the calculation logic to include shipping costs, so which was like previously excluded. So this AI should diagnose the problem, the data problem instantly, like without having a human to define each and every rule to reason. So that's what dependency mapping will help with. Number two is casual analysis. This is again super important. This is the intelligence layer. So the AI automatically analyzes correlated variables to find the true root cause of a business outcome and not just a data error. So it uses metadata understanding to ask, is it traffic or is it price or is it the availability? What moved the needle? So if a business metric, say customer conversion rate is down by X%, the AI just doesn't just say the number is red. It says conversion is down, but your traffic is up and price is stable and inventory availability for the top five products have fell like by y%. So that is the AI diagnosis that can show the operational cost proactively. So casual analysis and dependency mapping are the two key factors that would help AI reason the best. And last but not the least, narrative generation. So this highlights the critical output of metric lineage, where you are turning data points into executive narratives. The reality is executives always want a story. Your leaders want a story, not a spreadsheet. And today an analyst spend hours of time compiling that story, so sourcing data, vetting numbers, and writing the summary with caveats. And this AI native system, it totally shortcuts this, by having full confidence in the lineage and the casual analysis. AI can generate a narrative with source context. So it essentially writes the first draft of your executive summary. For instance, gross margin decreased by 2% this month because of a sudden spike in component cost, not due to a change in our pricing strategy. And this is an operational issue, like reporting immediate action and providing a recommendation that, okay, hey, you need to find an alternate supplier for this particular vendor. So that's the kind of narrative AI can generate with the help of both dependency mapping and casual analysis. Let's move to the next. Proactive intelligence. This is again, like super important. Our traditional dashboards are fundamentally, flawed because they are pull systems. They require users to constantly click. They have to filter and they have to drill down and forcing this human to hunt for that one thing that matters. Though dashboards are fantastic, yes, they provide a lot of context, they provide you drill down facility, but it also comes with a cost, and that cost is tribal knowledge. A vendor manager, for instance, today looking into a dashboard should have tribal knowledge on understanding what that metric is, how does it function, and what this dashboard has to offer for me. And if you are a new business user, you have to work on a ton of wikis or knowledge sources to understand this, to understand and gain this tribal knowledge. That's where proactive intelligence will transform the whole low navigation of your existing dashboards. What we call as low touch navigation. Proactive surfacing. So the AI agent monitors the entire business state and your dashboards, and then it will automatically alerts you when it detects unusual behavior and provides the why immediately. So Instead of logging in to find a problem, the problem actually comes to you, and it can come to you through different means. Like today, there are a lot of reporting tools, both Tableau, QuickSight, and other reporting tools, enabling communication through, like Slack or Teams, Zoom, like all these different communication channels. So you don't have to go to a dashboard. You get an automated alert through your communication channel, and also an automated like recommendation on what to do next. So that's proactive surfacing. And contextual guidance, as of course, it provides you like what needs to be done. And NLP drill downs. So when a user logs onto a dashboard, it automatically greets you like, okay, hey, Rajesh, welcome to this dashboard. I see you are a vendor manager on this particular department. And I can provide you a quick summary of, like highlights or, like opportunities that you have. I have identified from this dashboard for you and for your department, So enabling that conversational drill downs without having the user to go, like spend a ton of time to drill down each and every tab and view in the dashboard. So that's NLP drill downs. So this whole transition from high touch self-service to low touch proactive service is where AI truly guides decision makers and dramatically improves organizational efficiency. While we talk about AI native, we must address the single biggest challenge, trust. Like especially with generative AI, the risk of hallucination or the risk of fabrication or the incorrect output, simply bad business advice, right? Which is super real. We cannot trust a black box with high stake decisions. So what is the solution? The solution is human in the loop analytics. So this is the essential mechanism to combat mistrust and ensure the system, like continuously improves. And the loop is simple. AI generates, the system produces an insight or a recommendation. For instance, a suggested inventory rebalance plan. And then the human validates. So the human reviews the finding. They check for local knowledge the model might miss. For instance, a regional competitor just opened. And if the AI is wrong or incomplete, the human overrides it and provides structured feedback. And then this feedback, right, the system has to learn from it. That's what we call reinforcement learning. So the human validation and the corrected action is immediately fed back into the AI model, the semantic layer and the metadata, improving its accuracy. And it reduces the future drift. So the systems learn not just from data, but from validated wisdom. So this isn't about replacing humans. It's about leveraging the human's domain expertise to audit and train the AI and making the entire system safer, more accurate, and ultimately, like more trustworthy. Because without trust, you are not going to enable AI recommended actions. So the human becomes the AI strategic partner and editor. And of course, as technology leaders, we must be practical. We need to address the real world headwinds. And this is not a magic solution. It is what I call a disciplined engineering and governance effort. So data drift. Of course, the real world is messy. The customer behavior changes. After a pandemic, economic cycle shift, the seasonality also moves. Um, and explainability. If the AI makes a mistake, if it recommends, say, a $10 million promotional spend that fails, we must know why. And was the input data wrong? Was the algorithm flawed? Or did the business logic change? So this is essential for debugging and crucially for regulatory compliance in areas like finance and healthcare. We cannot allow a black box in core business stations. So explainability is the key, and you can use frameworks like Sharp to introduce why an AI is making this decision. Along with explainability, it can also provide traceability. Where this decision, like what all metrics, what all systems have been, part of making this particular AI recommendation. So explainability and traceability plays a key role, and compliance and sustainability. Yes, You need to make sure every decision must be auditable and it is adhered to the privacy laws and operate within the budget, of course. This brings us a topic that is licensed to operate today, responsible AI. We need AI to be green, ethical, and at the same time fully compliant. So the path forward requires us to build a governance framework before we deploy the agents at scale. And how do we prove ROI? Of course, there are a lot of metrics that we need to start measuring, because without measuring metrics, you're just talking about strategy but not implementing it. So here are some of the key metrics: decision latency, the time taken from data availability to an actionable decision being implemented, and at the same time, adoption, which we do today with AI or without AI across any tool. So the rate at which AI-driven recommendations are accepted and applied by the users. Outcome lift, of course, is the financial metric, incremental revenue, margin, or cost avoidance, and decision reversal rates. This measures the trust and quality. It's a percentage of times a human reviewer overrides or rejects the AI final recommendation. It is super crucial, and it really indicates the low trust, poor explainability, or an unreliable model. So very important to look at decision reversal rates and model decay rate. This is purely tried to drift detection. So long-term stability of the metric and feedback loop. This measures the health of human in the loop system. How quickly, how accurately does the human provided feedback, and how did that improve the model in the next iteration? You need to totally measure all these kind of different metrics in order to ensure the AI recommendations are accurate and reliable. And of course, responsible and sustainable AI. These are not buzzwords any longer. They are a leadership mandate and, frankly, a prerequisite for public trust. So, ethical AI governance, green AI, and data sustainability, and at the same time, building trust. This is where the rubber meets the road on our societal responsibility as technology leaders. Moving on to the future, the ultimate vision for the future is the rise of agentic analytics ecosystems. We move beyond a single siloed models to a coordinated network of specialized agents. Like, say, you have a data curator agent, you have an insight generation agent, and then you have a decision advisor agent. So the true power is when all these systems can observe, reason, and act autonomously, or at least the nearly so. So the ultimate example for a fully autonomous pricing engine, say the data curator agent monitors real-time inventory, and it monitors competitive price changes across thousands of products. And then the insight generator, it will detect that a key competitor has dropped a price on a high margin item, and this would trigger 20% loss of sales prediction. So then the decision advisor comes in and dynamically refreshes the pricing model with the new data and executes a pricing update in the ERP system within less than a few minutes. So this concurrently sends an alert to a category manager with why and predicted sales lift. So if at all the manager, the human in the loop, believes this is not an accurate recommendation, they can go stop executing the particular action. So this is how a self-driving enterprise where human capital is focused on high-level strategy and innovation, and they should not be on operational monitoring and data plumbing. In closing, analytics evolution is definitely profound. It is moving us from basic data visualization and reporting to an empowered decision intelligence. So the opportunity is to build AI native systems that enable conversation, intelligent reasoning, and responsible autonomy. And call for action. As I said, you should start investing in metadata. Make metric lineage and semantic layers a top priority. And agentic governance. Start defining frameworks for monitoring and auditing these AI system decisions instantly. And decision reversal rates, fairness scores should be on your executive dashboard along with a business performance review. not seen as a separate, like operational efficiency scorecard. And ethical AI, of course, embed fairness, sustainability principles into the foundation of your data architecture. Thank you for your time and attention.